Yes. Perfect start. Hello, everyone. So after a very bumpy start from myself, oops. Yeah, I want to really welcome you to this JEC session today. My name is Hannah Damas, and I look forward to a really interesting session with top-level speakers, I would say. The theme of our session is Composites Manufacturing 4.0. And what we have discovered backstage right now is that we are quite analog, most of us, because we take notes on paper still. So maybe we'll see how digitization is maybe a benefit for the composites industry, although we are taking notes still on paper. Today, we want to discuss the latest advancements in digital design tools, simulation, process optimization, and smart manufacturing, and how this all can be applied to composite production. So we would like to explore how these cutting-edge technologies are reshaping the landscape of composite manufacturing. And I look forward to discussing how Manufacturing 4.0 can enable faster production, reducing materials use, improve product quality, and also enhance customization. In summary, the question we would like to answer today is, can efficiency and sustainability be unlocked through automation and digitization? So I would like to introduce the people that are sitting here. I would like you to introduce yourselves. So maybe Jose, we will start with you. Tell us a little bit about yourself, please.
Thank you. Hello, everyone. So my name is Jose Feigenblum. My background is in material processing, and we are working with the company I represent, Rocktool, in molding activities in injection molding, and it's why we are at the GEC in composite processing. So we offer induction heating technology for the molding. And I'm a CTO and now innovation director for the last 10 years.
Thank you. Cornelia?
Bonjour, good afternoon. My name is Cornelia Bayer. I'm here with the company Sense Expert. It's a brand, and we belong to a group of companies with niche. My background is not in materials. I'm from the economic side. So over 20 years now, I'm in business development, developing companies, new business models, revenues, translate core technologies into innovation and helping them to think out of the box. So thank you for having me.
Enrique?
Hi, I'm Enrique Garcia. I'm the Chief Technology Officer at the National Composite Center. It's an R&D center in the UK. 450 people, quite a lot of technology, and I'm really looking forward to talking about this. Actually, it's one of my passions, really.
Cool, thank you. Mitchell?
Hello, I am Mitch Smith. I am from ST Engineering in Baltimore, Maryland. We manufacture aerostructures, and I've been in the business for about 30-some years. I'll preface it as I am not a digital technology expert, but I do lead our digital thread developments at our business and work closely with Avner and some of the people here. So thank you for having me, and this should be excellent conversation and to hear people's different opinions.
Thanks, Mitch. Avner?
Good afternoon, everybody. My name is Avner Ben Bassat. I'm the CEO of Platane. We are a software company focusing on production, automation, and optimization. My personal background is mathematics and computer science. So the core technology is AI, but really, how do we elevate the level of digital? And really, what do you do with the data in order to improve these efficiencies? So thank you again for hosting us here, and I look forward to it.
Thank you. So I guess I conclude the round. My name is Hannah Damas. I'm the head of composite production at the Institute for Textile Technology in Aachen, so part of the WTH Aachen University. And we are doing research along the whole composite or textile process chain, so really from fiber production up to the final part. My specialty is also automation and digitization and how this can be used to unlock efficiency and also sustainability. Okay, so let's really deep dive directly into the first topic, which is digital design and simulation. Enrique, I would like to ask you, how are digital design tools and simulation software revolutionizing the design and development of composite products?
Thanks, that's a really good question. So I think that we in the composite industry have been pretty good at understanding that design and manufacturing go hand in hand together. We move from black metal probably in the first generations all the way up to really optimized products. And that is basically thanks to the understanding of the manufacturing processes, but bringing those rules and all the understanding into the design and the simulation. So I think the quickest way to answer this is accelerating product development is basically what, and further optimizing basically. So all of the design tools and the simulation tools that allow you to really understand what performance you can get out of the whatever you're designing, but also the simulation of the manufacturing processes, and then the linking of the two, simulation of the as manufactured, let's say, performance. That is helping massively in accelerating and further optimizing the product development, basically.
Thank you. What are you working on right now at the...
Well, we have so many active projects on this, basically. But, I mean, we're working quite closely with some of the universities that are developing new algorithms and new way of accelerating some of the simulation tools so that we can actually do things almost on the fly, all the way down to using AI to accelerate also the creation of models that allow us to do faster designs, but also rapid implementation of the embedding the knowledge generated in manufacturing and in process all the way down to the next generation of design. Does that make sense?
Yes, completely. Thank you. So maybe with that, maybe there are also some challenges, but also opportunities. Yeah, while integrating these digital design into the composite manufacturing processes. So Jose, what's your thought on this?
I will say, first of all, it's a new industry. Saying that, if you compare with the metal industry, with steel working, it's definitively new. So even if it's a new industry, they have less experience. But I think the new tools, new softwares, new approach is matching well with composite industry. From my point of view, the simulation difficulty is also linked to the material itself. The composite, first, it's a mix of two different materials. As soon as you start to think about simulation, finite element analysis, simulate fiber with a small mesh, it's always a big difficulty. So there is always some difficulties linked to the material and the combination of the material first. Yeah.
Yeah, that's also what we discovered at our institute. Yeah. So Avner, what do you think? How can digital technologies be used to optimize material usage and reduce waste?
Well, the quick answer is there's a lot of opportunity. When we look at the production processes today, a lot of them are very much manual, paper-driven, and we see a lot of decisions in manufacturing that are made by production staff very locally, not always with the proper data or the guidance or the ability to look at the big picture. So in a way of a two-step process, first digitizing the data from multiple elements into one place, then someone or something can look at the data and then make better decisions. Which material to use for which job, what's the right allocation, how do you best monitor expiration of materials and use them in time? How do you then monitor the parts? Mistakes along the way or suboptimal decisions will lead to waste. Scrap of raw materials, scrap of parts, which is even more costly. And we see a lot of opportunity by digitizing this and then applying the algorithms on the data to then guide the team to do the better job. Which material should I use today? Which should I save for tomorrow? If we're talking about ply cutting and hand layup, what are the best ways to process the material? So there's abundance of opportunities stemming from the fact that the processes today are analog and that all decisions are really made by people in a very unorchestrated manner.
Thank you. Mitch, from your point of view as a producer of parts, can you confirm that?
Yeah, so for us, you think about, and for those of us who build hardware in the industry, you'll notice that for hand layup product, we buy a very expensive broad good, right? It comes at 60-inch wide or whatever. And then we nest it. So our digital thread coming out of our system for ply definition, and with a broad product suite and different specifications and different materials, what we find is that you don't necessarily have the opportunity to optimize your usage of that material. So for instance, in the US, we pay roughly about $100 a pound roughly for everything that we buy, sometimes a lot more expensive. So while some nests, which is how we pack in all these 2D ply shapes, we can be fairly efficient, 99, maybe 92%, right? But there's many times that we're not, because either the ply itself or the part geometry doesn't really allow us to utilize the fabric in all of its purest form and to get the most out of it. So on average, let's say we buy $35 million per year, right? On average, we're probably throwing away 10 to 15% of it. Well, it's a pretty sizable amount of money. So one thing that we've done with Platane and what we're trying to do is that by really actively mixing product and part together, so instead of cutting single nests, instead for a single component, we look at our week's plan, we dynamically nest all of them together. It complicates sorting and kitting for sure, so some of our parts are 600, 700 plies that have to be managed. But those efficiencies that you get by doing that intense packing on your raw good materials, even if you can take that 15% and make it down into 5%, over the year, it's a significant cost savings for the business. And for us, it's important, right? It's those little nickels and dimes, not really nickels and dimes, but you know what I mean? It's that smaller part that really allow you to be really efficient, and it helps you in the next product launch. Now you have a system in place that allows you to be very optimized and much more cost competitive on those future programs. And that's really what it's about, is developing that digital system to allow you to be much more competitive on the programs coming up and to optimize what you have in your current your product stream that you're actually building.
Yeah, thank you. That's quite the perfect transition to our next topic, maybe. Enrique, I would like to ask you, how can process optimization techniques be applied to composite manufacturing to improve production efficiency and also quality?
Yeah, so I think it's related to the previous question, I guess, but we've been doing quite a lot of work on moving from part inspection to in-process monitoring. So sensoring is absolutely critical, and getting the right data and being capable of analyzing the data and building models as quickly as possible. So one of the things that we're doing is most definitely trying to develop those models, capturing the data, going through the pyramid as quickly as possible, basically, and then translating that into better design instead of locking the design and then starting looking into how we can improve the quality. It's a kind of like blending the V of engineering, so we don't have the handshakes anymore, but in-process monitoring is becoming more and more critical to actually do that, so the sensoring is one of the absolute critical parts, and getting the right data is becoming more and more important.
Yes. Jose, is this also your experience, or?
Like Avner said, the composite industry is still very often manual. So I will say the trend to push automation, robots, cobots, the use also of machine learning, I think it's coming, and definitively it will help to improve efficiency and stability of process. But I think some industries are pushing, or let's say pulling for this. For instance, the aerospace industry, you know better than me. But I think the rest of the industry is trying to follow this trend. Yeah.
Mm-hmm. Cornelia, what do you think? What role can smart sensors and data analytics play in real-time monitoring and also control of composite manufacturing processes?
When we look in the last couple of years and we talk about digitalization, I think a lot of happened already with intelligent machines, etc. But now, especially, I think a lot of has changed from last year's GEC to alone this year, and materials become more and more center stage. And this is really interesting for us. With the company that I represent, Netsch, we are historically grown within the material characterization, material science field since over 50 years. And as this traditional company serving laboratories with the right machinery to characterize materials, we saw and explored the need of how can we enhance materials. So how can we really learn, and you just said it, Enrique, how can we really learn from the materials? And I would say that materials are the least innovative, or how you would combine materials with industry for all. And this is what we change. We know materials, and we have hardware equipment applying to understanding of materials. So what we did, and I wouldn't say that there are smart sensors, there are state-of-the-art sensors. We all know temperature, pressure sensors. We know infrared, we know ultrasound. And yes, we are working with the dielectric measurement principle. And what we did, we enhanced the sensors. We enhanced the sensor and make them smart by just moving the purpose. So out of the laboratory, we move sensors into the mold to get this information, what we need to understand how material really behaves in the process, because it's not a raw material supplier fault or the quality issue that the material behaves differently than you expect, right? So the deviations or the parameters that occur while processing depends on so many different things. We are seeing, when we talk about thermosetting now in this case, we see cross-linking, pre-aging, we see contaminations, we see humidity. There are so many influencing factors that determine the outcome of the final part, and with that, the efficiency. Yeah, so we make sensors smart, or we can make sensors smart with allowing advanced manufacturing technologies to come into play, and also using machine learning AI to enhance the information that we get. Yeah.
Yeah, that's really interesting, I would say. So when we have like all this data coming from your sensors or maybe machines and stuff, maybe Avner, what do you think? Can we use them for predictive maintenance? And how can predictive maintenance and anomaly detection within the process can be implemented to reduce downtimes and also to ensure like a consistent or higher performance of the manufacturing equipment?
So yes, I mean, almost by definition, predictive maintenance aims to reduce downtime or unplanned downtime. If you know something bad is going to happen, you might as well maintain the system, fix a problem in 5 minutes that would otherwise create hours of problems and faulty parts. Typically, the value proposition would be either in consistent quality or simply capacity. If the machine is down for 5 hours, then the machine is down for 5 hours. This is not particularly our field, but what we hear is that, yes, machines create a lot of data, and the companies that deal with it are really the better ones will find a way to use the data in order to predict the problem. What they don't have a lot is faulty data because the machines typically don't break down. And this leads to another complete topic of should we only use data? And now I'm going beyond predictive maintenance because there's always, or there's hardly ever, sufficient data. And here, you know, as AI people, really we try also to blend knowledge. I don't think any of us need a billion pictures of a cat to know it's a cat. It's a cat. So similarly in manufacturing, do we really need all that data to make a realization? Or rather, how can we blend the domain expertise, the engineering knowledge, the materials knowledge, the production knowledge, and find shortcuts in this acquisition for data? And that certainly applies to predictive maintenance, but also to other areas of quality or operational efficiencies.
How do you deal with data scarcity in that regard?
Okay.
Sorry.
That's okay. First and foremost, start from the problem you're solving and work back. We are trying to improve OEE. We're trying to improve on-time delivery. We're trying to improve whatever. Then there's a model to solve that problem. The model needs data ABC and doesn't need data XYZ. That's already half the problem solved right there. We see a lot of attempts where people would come to a company such as Mitch's here and say, hey, Mitch, give me all your data. I'll do some machine learning and something maybe will come out. That's very academic, but is not very practical because I don't think Mitch has too much time to give any of us all his data. And it takes too long in terms of time to value. So working back is step number one. But given what you have and what you don't have, yeah, I think a big issue is integrating the domain knowledge in order to put shortcuts in the process. And then you go into other domains of AI, of generating data and synthetic data and all that. But at the end of the day, manufacturing, especially in this field of composites, does not offer a lot of data, not yet. And that's an issue for the time being we need to address, but we are successful in doing so. There is value to achieve for sure.
Thank you. Yes, so hopefully one way of getting more data is introducing automation techniques. So for example, you already mentioned robotics. Cornelia, I would like to ask you, what do you think how robotic automation and also advanced manufacturing technology is transforming composite manufacturing processes?
While we see robots and we have this in the background for automation, and there's a lot of going on, smart factories, everything is automated. I would like to add to what was said. Having data on hand, we all have loads of data on hand. The problem and the issue is that we have, or the challenge that we have is we don't know how to interpret the data. We are humans, we are material specialists, we are process engineers. We know how our process works, but we don't know, and we are not AI experts in how to interpret the data. And then there's loads of solutions out there that provide you with different kinds of software tools, etc. So being a machinery supplier ourselves and coming from the hardware side, we saw that, I mean, it was our need as well. So we needed to understand how our main competence and our core competence can be translated and really helping and supporting our customers with having and interpreting this data. So I can refer and talk about advanced manufacturing technologies and how we do it and how we use it. And I would like to maybe give examples, because we have different kinds of experience with players here. We have solution providers, suppliers, we have the big global OEMs. And what we see on a daily basis that we come to factories which are really, really good digitized already and having automation tools in place. But being someone with AI knowledge or software knowledge doesn't mean that you really can help interpreting the data. So when I give you an example, we have a client completely digitized, all the automation you can imagine, really in a smart factory, using advanced AI and software, and having a data scientist team of 50 people. And they were looking at 40 different kind of process parameters to create the most efficient process. And they failed. 6 months of trials, cost a lot of money, nothing. So because we understand materials, because we see what is going on in the process, we installed our technology, and within 1 week, one person, one data scientist was working on the issue and present them the most efficient process. And not because we are so good or we are so cool, no, simply we understand the core competence, and the core is the material, to understand how the material works and the characteristics behind it. This made all the difference. So by using your core knowledge, and this is not, we didn't invent anything new, but we understand the material, we have the professionals behind it who are experts, engineers, material scientists, and just took what is out there with the digitalization and the advanced AI and machine learning to create a technology that works based on our ground truth, where we came from, right?
Yeah, thank you for this very good example. Speaking of examples, Enrique, do you have any specific applications or maybe examples for robotics in composite production in mind?
Yeah, absolutely. I think, I mean, if you think about automated deposition, for example, the way it started was with big countries and very complex systems, and things are going in the right direction, I hope, which is simplifying and using robotics as quickly as possible, because the investment that you need to actually implement certain things is significantly smaller. So definitely getting into automated deposition, and that's the traditional, let's say, fiber placement and things like that, but also more complex and closer to manual lamination technologies. A lot of these things are happening thanks to robotics. We have cobotics also in terms of possible augmentation of the manual lamination through the use of a robot in combination with the manual worker. To be honest, in every single manufacturing process that we see on composites, robotics are playing a role right now. So definitely in the inspection side of things, yeah, pretty much everywhere, to be honest. It's, they're getting more and more pervasive.
That's good to hear. Jose, what do you think? How can robotics and automation enhance the safety of composite manufacturing workers, especially in handling hazardous materials?
I don't want to oppose two fields, thermoset industry and thermoplastic, but as we know, If we can, let's say, refrain for human to work closely to the chemistry, whatever it will be, the mixing, the spraying, definitively it's always better. For both industries, thermoset and thermoplastic, also the trimming, which is you know, the CNC machining, which is creating some particles. It's already used in a lot of industries. It's always also better. So one more time, automation, robotic is not here to replace workers, but is more to help and to provide a better environment for the workers. Another maybe a thing, maybe linked more with the automation, can be also to create some environments to highlight and to support for the training of workers. And you can create a kind of digital environment, and in that way, for the workers, for the people working in this industry, to have more know-how, and in that way to protect and to create a safer environment.
So some kind of human-machine interface where they
Yeah. can...
Okay, exactly.
Definitively.
Yeah, that's interesting. Mitchell, do you have something like this already in your factory or in your plant?
Yeah, so we have a pretty even split between I would call manual operations and AFP. I think the interface between the advanced robotics that we're using is really around optimizing the manufacturing process for your particular plant facility, what you have going on. For our operators, what we really want is like, and I don't know how it is for you guys, but for us, the human capital part of our business is incredibly hard to manage. Once you get people, it's hard to find true technicians, and then you get them trained. So now you have this very technical, competent person, and you want to retain them. So what the robotics do for us is it allows us to offer, I would say, a higher technical level of learning for them, which is less straining on them physically. I think it's rewarding in two respects, is that they feel much more part of the advancement of the business and the products that we're making and their involvement in it and what they bring to it, and not just a worker who's out, you know, laying bricks or just putting down plies or doing stuff like that. So that's the advantage for us for the entire workforce. And what it does is that the more automation we bring in, we never view it as replacing people. It's really enhancing their work. And actually, we usually end up growing because it allows us to put more capacity through the factory, build more product, and grow the business. And I think I think those old school thoughts that people used to have that, like, you know, robotics are going to replace me and they're going to, I think that in the younger generations, the people we hire, those thoughts aren't in their minds. It's natural for them to see it. They see it on their phones. I mean, good Lord. I mean, there wasn't a long time ago, it was flip phones, right? So I think it should become natural to them, so they embrace it right away. So in our factory, it certainly has helped on, you know, the amount of lost time, the amount of accidents, things that we almost have no issues with our robotic systems. All of our issues are still our traditional manual processes that are inherently have risk involved in them to our employees, which we don't anymore.
Yeah, that's really interesting. I did some research on also introducing robotics into composite production processes, and we did a lot of expert interviews and stuff, and we also saw that there is no fear of getting replaced by a robot. It's kind of a myth that is really sticking. I don't know why. So it's interesting that you see it the same way. You also talked about that you have like this long training processes, for example, for your workers. Compared to a robot, what would you say, which one is learning faster?
So I would say, honestly, the hand operations, much longer learning curve. I mean, if people who manufacture hardware, you know, countersinking, hand layup over core, adhesives, debulks, all the fine details to minimize voids and wrinkles and backside depressions, all kinds of things that cause havoc for us, right? That training, really, to be a good technical operator for us, it's probably close to 9 to 12 months.
Wow, okay.
So 90 days, we put you on the floor, but honestly, to be somebody you can be like, okay, you're hands-free, don't worry about it, it really takes almost a whole year. On the robotics side, it's usually within 2 or 3 months. We can bring something in. You've done enough pre-work to get it to a point. It's really getting the operator comfortable, and also those unpredictable things that do occur with robotics. I think there's this perception, certainly by some senior leadership perhaps, that you plug it in, it goes. It's like some oven or something, right? But it's not. There's always some nuance to the robotic system. There's always some, and it's just, because there are humans involved, so there's an entire system around interlocks and safety and what you can and can't do. I find that we had a system, we built 3,000 units with it, never had a single failure, 99.999%. Then we had a failure. So it's interesting, you'll find the series of events that a person can take or the system can take to find that one spot. And it's really about figuring out how to eliminate that from the whole system. But it certainly is shocking to us, right? We're 3,000 units in, it's been perfect, oh my God, it's the best thing in the planet. Then all of a sudden you have one, you're like, wow, we misdrilled all those holes. And so what are you gonna do, right? So I think that's kind of where we end up kind of being at for how we're gonna integrate the human to the actual.
Hannah, if I may,
Yeah, sure.
there's a kind of a way of thinking I'd like to introduce. We always refer to it as the man-machine team. And the idea is that this team performs better than any one of them individually. Machine or software do things very well. People do things very well. And we need to find the balance, this interaction, so that the outcome is superior to either of them separately. Certainly, as we introduce better new technologies, we move up the bar, which is great. The team continuously gets better. So to Mitch's example, it's not about displacing the person. It's about taking it to the next level. So overall, there's better performance, better quality, better productivity, whatever it may be. And this is really how we think about it also in terms of our R&D approach. What is the person's involvement? What is the software's involvement? What's the right balance? What's the right interaction? And this way, it's also a very practical approach because it's a journey. Whatever a company does today gets better and better over time. And so will the technology, so will the coordination. And then, of course, you benefit from HR retention and so forth.
When thinking about like the Industry 4.0 principles, like cyber-physical systems, you call it the man-machine team. What do you think, Avner? What are the key challenges when integrating these technologies?
You can go first.
Okay, I'll go first. Well, one of the challenges is gaining trust. Okay, so we work with people who have been doing their job, forget 40 years, 10 years, only 10 years. Okay, and then comes this technology, and it does a job that it used to do before. Whether it's a robotic process or a software decision, we do production planning. Why is our plan better than what this guy has been doing for 40 years? And with any relationship, man-machine team, you need really to earn this trust, and you can't really demand it. It's a process. Now, how do you earn trust in this world? Certainly. Well, you consistently make good decisions or good performance, something that the human will say, okay, that's pretty good. And the other thing we're always cautious about as practitioners is don't make the glaring mistake. Don't produce something or give a recommendation or a decision that's absolutely, pardon my language, stupid. That sends the relationship, the trust, way back. The analogy for all of us is the apps for navigation. When it came out, all of us thought it's a waste of time and we're smarter than it, especially the guys in the room. Now, over time, we learn to trust it up to a point where it takes the wrong turn. And then that trust cycle resets itself. But today, it's a no-brainer. And certainly for the younger folk, 22, 25 years old, they've never seen anything else anyway. Per Mitch's comment, they expect it. And then you go on to the next level and the next level.
Thank you. Enrique, would you like to add something?
Yeah. I think that I completely agree with you. That's once you get in the business. I think one of the main challenges is actually managing to get there. So justifying for the big business is not a problem, but when you're talking to SMEs, to small companies, justifying the investment in Industry 4.0 is very difficult. So building the business case, so it's not even the trust of the practitioners, is you need to convince the senior management this is going to be absolutely paying off in X number of months. And that is very difficult, I think, because it's managing expectations, right? I mean, some people are, okay, so I'm going to put like this teeny tiny amount of effort from my side, and then I'm going to reap off the benefits. No, that's not happening. I mean, you need the practitioners to actually do the job. And then the other one is, okay, so I'm going to invest like this tiny amount of money, and then I'm going to be completely capable of doing things. But I mean, for me, I mean, we do a lot of that actually. Just we're not selling any software. Where we suggest people like Platane when companies come to the business. But basically, what we have found is that making sure that you convince people to make the first step, that is a real challenge.
When you try to convince them, what do you tell them? What are the biggest opportunities?
So hard numbers are usually working pretty well. So I mean, it's the kind of things that Mitch mentioned. Identify the low-hanging fruit as quickly as possible, see the benefits that you can reap, and then from there, there's a whole journey of things that can be done.
Thank you. Cornelia, what do you think? How can data integration and connectivity be leveraged to create smart manufacturing solutions?
Yeah, good question. I would start with the investment side as well, right? Mm-hmm. So when we look at the trends or the industry trends in the composite industry, we have huge challenges. I mean, when we look at the aviation, it's contract fulfillment. I mean, it's a positive thing. Yeah, we have contract out there, but it's so much more. It's the labor problems, the labor shortage we have, skilled workers. So we need to integrate somehow data, or we have a lot of data on hand already. So when and how can we lever from that? So data integration and connectivity in an example of our case. So we have and worked with data from the lab. So we have static data on hand where we know, okay, this is before we go into serial production. This is how we need to put our process into the work mode, and then this is when we start. But in order to get rid of the challenges and be more cost efficient and be more productive, and we took and translated the data in a different context where we say, okay, the information that we get by integrating data into the running process by, and I said it before, by using sensors or other equipment to evaluate data that occur in the process or come out during the process, is that we said, okay, how can we take what is known? For example, kinetic model is the ground truth. We have material data sheets that is the ground truth. But then we see information coming out of the mold while processing it. So we combine, for example, those information that we have as a static display, and we use the real process data and combine this to create machine learning models. So ground truth, what we expect, but what we really see due to deviations from the materials, and they are often there. And when you think further for even recycling materials, it will be huge. So we integrate those information in the running process and allow to move away for production from a static process into dynamic. So when we see and we know in real time the cure of a part is not 50 minutes as it says in your static or material data sheet, but it's the automation and the technology that you have on hand says it's 40 minutes you can demold. When we talk about numbers and then it's investments, where you say, okay, you can cut down massive times to increase this efficiency. So this is how we integrate, for example, the data that we get on hand while being agile, while being real time. But then when we look about, and we heard it, digital threats, part quality control, big issue on top of that. So we connect the information that we get out of the process and using advanced cloud technologies, AI, artificial intelligence in our case, that sits in the cloud, that sees patterns change while they occur during the processes. And with that, we can retrain automatically your process. So you are always running at the most efficient point. And I think this is the importance of integrating data, but also having the support of people in the background and trusting the technologies that are out there, that you don't need to be let's say, an expert in AI or software, but just rely and trust the technologies that are there that bring you to the next efficiency stage. Yeah, thank you.
Thank you. Yeah, not only efficiency, but also recycling, for example, sustainability. That's also a big topic. Jose, what do you think? What role can composites play in the development of sustainable manufacturing processes or practices?
But the composite is offering a unique way to customize mechanical properties related to the mechanical or any function request. So, because you can also optimize the use of the material, it's the first step to try to limit the waste. I think new technologies, not new, but I would say the latest technologies arise, like the AFP, the 3D preforming. I think it's a way to explain, okay, we can provide the right performance at the right location, but moreover, we don't need to have a 2D sheet cutting and creating some waste. So I think the composite is offering this a bit differently compared to other industries. Second point for me, because whatever it will be thermoset or thermoplastic, the highest molding temperature will be about 400 C, is definitively lower compared to the steel industry or the glass industry. So the energy we engage on the process is definitively in a lower amount and with less impact. And maybe the last point for me is about the closed loop we can create easily, and now it's coming more and more. And probably also thanks to the thermoplastic to create a closed loop coming from a recyclable material, but moving to the recycling. So I think this is probably the big improvement that the composite industry can offer to the industry.
Yeah, we still have way to go, I would say, for the recycling and stuff, but yes, definitely. Mitch, what do you think? How can composite manufacturing companies adopt sustainable practices to minimize the environmental impact?
Okay, so for us, the way that we measure our sustainability is our CO2 GHG emissions per pound of processed goods. So we talked about like sensor technology, right? So for us, we have 10 autoclaves, 3 main high voltage feeders that feed those guys, right? They're by far our most non-sustainable, least energy efficient process by a long shot. So you talked about sensors, right? So our industry is a conservative industry. It's how we behave. And for all good reasons. For autoclaves, how we would look at something like integrating would be optimizing the autoclave runs to get more runs out of our equipment. It's good for the business. Autoclaves are large capital expenses. They're expensive to run. They're expensive to install. They're expensive to maintain. So for us, it's how much processed goods can we get through the claves. They are our cookie machine, right? We make cookies, very fancy cookies, but they're still cookies. So if we can shave 2 hours out of it, and by knowing, hey, listen, instead of this 3-hour hold that we have arbitrarily put in there, whether it's 50 parts or 1 part, that autoclave run is a programmed run. It's controlled by specs. There's nothing you do about it. However, if you had technology that said, hey, look, guys, you're 40 minutes in, you're fully cross-linked, it's time to dump it, then you dump it and you run. It's about efficiency through your factory. So I'm not really sure if that answers your question, but to me, it's how we become more sustainable as a business. There's a ton of inefficiency that just sits in how we consume power. It's wasted energy. So so there's 2 sides of it. It's either you just use less, right, because you're running the autoclaves less, or as a business, you make more money, right? We're all in this for revenue generation. So if I can get 50 more autoclave runs, it's 50 more sets of parts. Through 10 autoclaves, it makes a huge difference. And that's really what it's all about for us anyways, because we build hardware. It's about making more hardware and selling more hardware.
And I would like to add to this, because we see that daily. I got a call 3 weeks ago from someone who said, okay, we need to buy a new factory, we need to order new machines because we get so many contracts. So we introduced ourselves to them and said, okay, what is possible? Are you sure that you produce at the most efficient point? So we looked at them, and if you can reduce cycle times, and in this case was by 30%, investments, he could stop doing more investments on machines, energy, big issue, as you said yourself. And then if you could produce and fulfill your contract, so this is all that matters. There's so much untapped potential we have no idea about, and this is what makes novel technologies so much better.
Maybe
Yeah,
a small
sure.
point. I mean, the pressure coming from the cost for energy is not, let's say, new, but what we saw is it's a main topic now. Everybody is coming and talking about the energy costs, no compromise on other points, but definitively now today, the energy costs, the pressure, people which are producing is a key point in any development strategy for investment in any machine. So it's a topic number one today.
Avner, this is also something where you are supporting companies, aren't you?
Yes. So I think to Mitch's point, first of all, even tracking it is the good start. Like any production metric, OE, throughput, on-time delivery, carbon footprint. Certainly much more awareness, driven either by all of us understanding it's important, but also by regulations. And regulations could be government, but could also be the OEM driving it down. I think what the OEMs are also looking for is not only to be more sustainable, but to actually document it and show that you have been. So it's not enough to save energy or save material. You need to demonstrate that you could. And here, first, we see abundance of opportunity because it was really at no one's top of their mind until recently. And like anything, then there's opportunity. I think this was amplified by COVID overcapacity. We have enough autoclaves anyway, so we have other issues to think about. But now people are running out of capacity, whether it's equipment capacity, human capacity, or material capacity. I cannot just order all this excess inventory that I used to order. Now I need to be much more mindful of it, and that, of course, ties in very well to sustainability. So we see reduction of material waste. We see reduction of inventory to begin with. Less freezers and that whole energy aspect. The autoclaves are a big deal. I mean, it's a bottleneck, so it's a driver. Optimizing the autoclave drives higher throughput, but certainly translate into that metric of how many, pounds of carbon per pounds of product. If the autoclave ran half full or full, it's a big deal. But who is deciding on whether the autoclave should run now, half full, or wait 2 hours for a little bit extra? There's a guy or a lady making that decision today. And again, what data do they have? What are they looking at? What are the business goals? Are we always on time, or are we sustainable? And what are the trade-offs? So first, talking about it is a good start, measuring it, certainly, and then weighing the trade-offs, making the decisions. And this is all tied together. It's everything we've been talking about here.
And also maybe creating decision support systems for the people that have to decide, or maybe even do an automated decision one time in the future.
Or now.
Or now, yes. We can see sustainability from two angles. One of is the process sustainability, I would call it. And the other one is like the product or maybe material itself. Enrique, what do you think? What are opportunities for using recycled materials or maybe materials coming from production waste in composites manufacturing?
So we've been working quite a lot on this for quite a long time. Actually, it's funny that 5-6 years ago when we started this in Anger, not one single customer of ours was interested in it. But anyway, I think there's plenty of opportunity. The way we always have seen the recyclability or sustainability has been around the major principles. So it's reducing the waste as much as possible, making sure that you have a use for the offcuts, and then finding ways of repairing structures if we can, and then obviously think about the recyclability and how do you design for sustainability and how do you develop the technologies that allow you to recycle. So the way we have always seen this is cross-sector, and I don't think that we will find in the near future full circularity. I wish we could, but the reality is that what we are seeing is that waste from one or recycled materials or recycled components from one sector are extremely useful for the next sector. And this is where we think the future, the near future at least, is coming. So in terms of real applications, we're already seeing recycled materials being used in the early adopters. So sports are already using quite a lot of recycling or more sustainable materials, more bio-derived, things like that. And then regulations are driving quite a lot of behaviors also. So you see the wind industry, all of them being extremely interested in developing more sustainable solutions for their components. Other sectors are significantly slower, and we have to accept that. I mean, qualifying a new material and a new manufacturing process and a new product in aero takes a while. But there's a massive advantage in aero because the material is so good, let's say, that all of the other sectors are interested. So I think in terms of aerospace, for example, we will see recycled materials or more sustainable materials entering little by little into interiors, for example, and secondary structures. It will take a while for us to see a primary structure based on recycled materials, I think.
This is in our case, it's a really, really hot topic because yes, sustainability, recycling, somehow it's a blessing and we need to do it. We are living on this one world, but because on the daily business we see and we have to do with manufacturers and processors of creating parts, and you said aerospace, it's quality. So I would definitely raise, and I would be challenging this topic where I say, okay, it takes a long time, but why does it take a long time? Because the uncertainties that come with processing, recycling materials that you don't know the history of. So I am totally on the side where I say, okay, we need to do something, yes, but how can we support and how can we help those manufacturers that are under cost pressure, that need to provide quality, et cetera, et cetera. Yeah? So we need to provide technologies that are capable and able to detect those materials. So help them really to understand if I have a recyclate of, I don't know, a percentage volume of this and that and why, how can I use it, where was it treated before? And I think this is a challenging task that is coming. And Green Deal, yes, fine, we needed legislation pushes, yes, but they also need to take care of the manufacturers itself and help them with tools that they are capable of and understanding what is going on.
Jose, do you have the same experience when working with your customers?
Yeah, I think the main motivation as of today for people to use recycled material is because I think they are part of a virtuous loop showing how maybe they can integrate waste, or let's say with the PCR, you know, the post-consumer recycling material. Anyway, at least the most important is, the difficulty, like you said, is to create this loop, but the most important is to limit the use of new resources. And in that way, as soon as you can limit the use of new resources, you create something virtuous. A good example is about the carbon fiber. We know aerospace industry is a big one in the use of the carbon fiber, saying that a lot of other industries, they have also maybe a very small access to such material. So maybe for them, it can be a new option to try to have a new access, a good access for some carbon fiber composite or maybe a dry carbon fiber for their own application in sporting goods or other markets. So this can be interesting. Last point quickly, I think depending on your activity, if you're in B2B or B2C, we work in a cosmetic packaging and a plastic injection. There is a very close contact between the product and the customer. And now, for the customer, they have a very clear statement. They are very, let's say, taking care of the material. Do you have any painting, any decoration? What kind of material? Is it coming from the recycling material? So, a bit like we said, you know, the marketing is not the bad guy, but the marketing is very important because the customer or the industry, whatever your own customer or maybe industry customer, the customer, they have a very clear statement of what they want and what they don't want.
Yeah, that's really interesting. unfortunately, we're running a little bit out of time, so we only have like 5 minutes left. So maybe we will conclude a little bit the session. Mitch, I would like to ask you, what do you think overall, hearing what we have said, seeing all the innovations here in the halls, what do you think, what are the key trends and emerging technologies that will shape the future of composites manufacturing?
Okay.
Big question, I know.
So I think the amazing thing for me is when I look around the hall, the shift to additive manufacturing tooling. I mean, the sheer number of companies here who are selling 3D printing equipment is awesome. We ourselves buy it and use it, and it's been great for us, right? I think that transition from what I would call the traditional manual methods of building tooling and fixturing and all that kind of stuff, that's been great to see here. I would like one step back on the recycling topic, right? So that's something that, as an aerospace producer, it's super difficult. The process of getting anything through the FAA with the design allowable database and all, it's just a nightmare. So I would only implore for the industry here, and this is a great spot because you get to see all the industries, please help save us in the aerospace world. The opportunity for me to introduce a recycled carbon fiber product, it's pretty low. Maybe some very low value product, inserts and bushing, something that's like I can get away with it. But in the scheme of things, it's very, very small. The other adjacent industries, the derivative industries, they really have to help us, at least for my business, right? And I also notice here, like I go around the thing, we've been looking like, there's a lot of people who are selling recycled carbon fiber or recycled product. But I really wish that somebody would come say, hey, listen, that 50,000 pounds of trash, we'll take it. I've yet to find the section of the conference where the people are like, please ship us your stuff for free. You don't got to take it back even. Most people want you to take it back. But I think those are the things that I see for the trend of the industry. As we move forward, it'll be automation, this moving into this very customized ability to on the fly make tooling and fixturing and all those other kind of things. I think those are the things that I see at the show and the things that I'd like to see. I'd like to see more of that. I guess that's it.
Thank you. Enrique, what do you think? How can composite manufacturing companies collaborate effectively to really develop, deploy innovative solutions that drive efficiency, sustainability, and also competitiveness?
I mean, as I was saying before, I think it's a cross-sector thing. So it cannot be sectors working independently. I think some of the challenges are common to all of the sectors, and again, to some extent, what I was saying before. I mean, your waste is extremely useful for other industries. So let's just make sure that there is a clear understanding. Also, I mean, building on the aerospace thing, I mean, one of the things that the Composite Leadership Forum in the UK has done is making an analysis on the life cycle analysis, really, of the impact of certain things. And to be fair, in civil aerospace, 95, but depending on who you talk to, 95, 96% of the emissions of the aircraft are during operation. So it makes sense to actually have the best possible material you can put, because if you look into the overall life cycle analysis, it really makes a lot of sense to have the best possible material, even if it's not recyclable. I will deny saying this, but the whole idea would be to actually make sure that there is a second life for those materials. So again, I guess the shortest possible way of the answer is it is a cross-sector solution, and we need to make sure that all the different sectors that are using composites are getting together to solve this.
Coming from maybe like a data point of view, Avner, what do you think? How can companies collaborate maybe better to get the most of it?
I think, Enrique, you said before, low-hanging fruit. Mm-hmm. There is not one low-hanging fruit. There are a million of them. And there are multiple vectors that can help here. Sustainability is one vector, but it's long-term. Cross-industry collaboration, critical. Reducing the spec from an 8-hour run to a 6-hour run, it's going to take Airbus or Boeing 4 years to approve, if we're lucky. But if that autoclave is running half full, maybe that's easier. Just as a quick example, the numbers we're seeing out there are typically 60-ish% utilization on the autoclaves. What if all of us were running 65%? Forget 100. That's just a massive opportunity out there for sustainability, for money, for productivity, for capacity, for rate. There's a lot of opportunity in every aspect that the team here talked about.
Thank you. So yeah, I'm afraid this is going to be the end of our session today because we're out of time. However, good news, you all have the opportunity to meet the speakers. Right next to Agora 6, there's a speakers meetup zone. So within the next 30 minutes, we will be there. We can still discuss, answer questions, just exchange business cards, whatever. Yes, and I would like to take the opportunity to thank you all. A big round of applause, please, for these amazing speakers. Thank you very much for the valuable insights and fruitful discussions. I would also like to thank Benjamin and the whole GEC team for inviting us and hosting this event. Yeah, and with that, I would also like to thank you, the audience. Thank you for your attention, and yeah, see you soon.